Okay, we are going to look today at more word problems. We've been doing word problems with the big race and different things on Delta Math, and today we are looking at word problems with slope-intercept form, so it's all the same thing on this worksheet. So you need something to write with. Hopefully you already have that, and then this worksheet. Number one, I don't really like that it starts at 35, so if you guys would go ahead and cross that out, and we're going to change it to 9 feet. So the water level of a lake, it wouldn't really be a lake if it's only 9 feet deep. Maybe it's like a little pond, but that's okay. We're going to go with 9 just so that it works better with our numbers, with our graph. So suppose that the water level of a tiny lake is 9 feet, and that it is receding. I'm not sure if you guys know what the word receding means, but it means to go down. So it goes down. Basically, it's drying up. So if it's drying up, the water level is decreasing. It's receding at a rate of 1.5 feet per day. So in not very many days, this lake, this little mini pond, will be completely dried up. So we need to set this up on your graph. So if it starts at 9, that is kind of like if we were doing the big race, they got a 9-meter head start. So we're going to label our graph, count by ones, because our graph actually goes to 9, which is perfect. And remember, this is the amount of feet that your lake is. So we're going to put that our lake is this many feet deep. And then across the bottom is the only other thing we're talking about, days. So this is going to be days. So we can go ahead and count by 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one actually goes to 10. Remember to label your lines, not your spaces. So you guys need to set this up and make sure you're lining up your lines with your numbers, not the spaces. Okay, and again, this is the number of days. So be sure you're labeling your graphs. We're going to be checking for that on your assessment over word problems. So be sure you've set it up correctly and labeled both of the axes. Okay, so we're going to write an equation for L and D days. Normally that's Y and X. And so if you had set this up on your own and you went ahead and put an equation with Y and X, that would be fine. But since it's telling us to use L and D, let's go ahead and use L and D. So the total L, which stands for water level, is that it started at 9 and it's decreasing, it's receding, it's going down. So it's a negative at a rate of 1.5 feet per day. So it's going down 1.5 feet per day. So 1.5 per day, so that's a D, because it's going down 1.5 per day, plus it started at a height of 9 feet. So here's your equation. It's like y equals negative 1.5x plus 9, but we're using L and D instead. Now we need to graph the equation. So you're going to put your first dot at your y-intercept, which is where the lake started, and we're decreasing 1.5 feet per day. So we're going to go down 8 and then 7.5 per one day, another half and 1 per the next day, another half and 1 for the next day. And again, we're just decreasing by 1.5. So half, 1 per day, 1.5 per day, and then 1.5 per day. So that means if we go ahead and graph our line, we are completely out of water by day 6. So in how many days, this actually is going to change because we changed our 35. So let's change this to like 6. So how many days will the water level be 6 feet? So go to your feet on your label, which side is measuring feet, should be this one, and go to 6. So go to 6 feet, go out till you touch the graph, which is right here, and then read down and see what day that's on. So at day 2, it will be down to 6 feet of water. So if we want to know about 6 feet of water, that will be on day 2. Or 2, you could have just put 2 days. Okay, so I really want you to be able to graph a line, to write an equation for it, and then to be able to answer questions about it. So, and again, we've done y equals mx plus b for so long now. It's just that your slope is going to be your rate. your rate at which whatever is increasing or decreasing, and then your y-intercept is always where it starts. Okay, so number 2 says Tina babysits after school. That should have been a space. Sorry about that typo. She babysits after school and charges a flat fee of $3. That is, by the way, not enough money to babysit. But she also adds $5 per hour. So just to come over, just to drive to your house, she's going to charge you $3 plus $5 per every hour that she's there. So let's write an equation for the cost. That's the total cost, C. So we're going to start with that. And it equals how many hours, so how much she's paid per hour, plus her flat fee. So hours is $5 per hour, so 5H, $5 per hour, plus the upfront fee that she starts with, which is $3. Okay, there's your equation, and again, if you were using y and x, it would have been y equals 5x plus 3. So this is your rate of change or your slope, and the 3 is how much you start off with. So what do the slope and y-intercept represent? Slope is $5 per hour. So it's how much she's getting paid per hour. And the y-intercept is the $3 up front. So just to drive over to your house, she charged you $3. That's your y-intercept. And now we can graph the equation. Remember, to graph the equation, you have to set this up correctly. So let's count by ones. Be sure you're counting by your lines, not the spaces. And we can also count by ones this direction too. Okay, at which we only get up to 9. Okay, I've told you guys this before, but if you are wondering which axis represents hours and which one represents money, anytime you have time is always independent in math. So we're going to put time on the bottom, and that is hours. And so if you ever have money, if you're ever measuring dollars, that's always going to be dependent, because you always make an amount of money depending on how many hours you use or you spent or you're there working. So our y-intercept is 3. You're going to go up the y-axis and put your first dot at 3. And she is going to make $5 an hour. So after 1 hour, she's made the 3 she started with plus $5 more for that hour. So she's made $8 after 1 hour. And I probably should have counted by something more, because we're only going to be able to get 1 dot on there. But I'm going to draw an arrow on the end, meaning that would continue. We'd go up 5 over 1, up 5 over 1, because the slope is 5, because she's making $5 more every hour. Okay, so we graphed it. How much would she make if she babysits 5 hours? So I don't have enough graph to show you where it would be at 5 hours. So for that reason, it's really good that we could do an equation, because you can just plug in 5 for your hours and multiply and then add. So if we know 5 is the number of hours, that's the H for hours, and we're wondering in 5 hours how much she made. So we're going to do 5 hours times $5 per hour plus the 3 that she made to start off with. So 5 times 5 is 25 plus 3. 25 plus 3 is 28. I can do math, it's okay. $28. So in 5 hours, she would make the $5 per hour. So 5 times 5 is 25, 26, 27, 28. Okay, let's do number 3. This is our last graph on this front side. Let me widen this up a little bit so you can see it. Okay, an electrician charges $25 just for the service call. That means just to come out to your house. They're going to charge $25, basically just for showing up. Plus, they're going to charge you $50 per hour that it takes to work. So we're going to write an equation. C is the total cost that you would pay them, and H is the number of hours of service. So we're going to start with the total C cost, and it costs $50 per hour. So I'm going to go ahead and do 50H. Plus, just to come out to your house, they charged $25 up front. Okay, It says now we're going to graph that equation. I'm going to be a little bit more intentional about what we count by because we obviously can't count by ones since we need to get up to a slope of 50 and we need to get up to 25 here. So let's count by fives. Let's see how that, well, I think we need more than that. Let's count by tens. So our money is going to start at 10. Again, be sure you're labeling the line, not the space. So 10, 20, 30, 40, 50, 60, 70, 80, 90. And then this is, and that's always money. Money is always, how much we're charged is always on the y-axis, and then time, how many hours this electrician works at your house, is always going to be the x-axis. So time in hours is going to be 1, 2, 3, 4, 5, 6. Hopefully they're not working at your house for this many hours, or you're going to pay a lot of money. So we need to put our y-intercept at 25. That's how much they charge just for 0 hours of work, just to come out to your house. I'm going to put it right between 20 and 30 because it's 25. You are paying an additional $50 every 1 hour. So in 1 hour, it's going to jump up to 75 because we have the 25 just to come out there plus the 50 for 1 hour. So again, this is probably not what I should have counted by. Probably should have counted by 25s or even 50s. So not a very good representation because it's going to be very expensive to have them there more than 1 hour. Okay, but let's go ahead and use our equation to find the total cost for if he happened to work for 8 hours, he or she. That's a lot. That's going to be very expensive. So instead of just H, we know we want it to be 8 because we're asking about 8 hours. So we're going to take H, which is 8 times 50 plus 25. So 50 times 8 is, okay, I know it's 400, but I'm going to go ahead and do it in my calculator because you guys can always use a calculator. So 50 times 8, and then we are going to add the 25 because remember, they're also charging us $25 just to show up. $425. So that would be a very expensive electrician. Okay, here's a backwards problem. Now, if the electrician only earned maybe not $425, maybe if they only earned $225, how many hours does that mean that they worked? You can go ahead and work backwards, but I'm going to show you that if this is the total C cost, then it's like putting $225 right here. So you can set up your equation like this. $225 equals, because that's the cost, 50H plus 25. And you can solve it this way. And again, if you guys already did it and worked backwards and solved it, that's awesome. But if you want to practice using your equation and being able to set it up, the 225 would be the total cost. So that's why I put 225 here. So you would just solve it. You would subtract 25 from both sides. And those of you who did this in your head already probably didn't set it up like this, but I bet you first subtracted 25, which gives you 200. And then you divided that by 50 because you know that the electrician makes $50 per hour. So if you divide by 50 on both sides, 200 divided by 50 should be 4 hours worth of work. So the hours would be 4, or 4 hours, however you want to say it. Okay, let's turn your paper over to the back and try a few more. All right, Riley collected 125 pounds of aluminum cans to recycle. He plans to collect an additional 25 pounds each week. Okay, so let's write an equation first. The total P pounds of aluminum is equal to the 25 he's going to collect each week. So 25 per W they want us to use for weeks, plus the original 125 that Riley already has. Okay, what do the slope and y-intercept represent? The slope is 25, so that means that's the 25 per week, pounds per week. that he will be collecting. And then the y-intercept, that is the 125, and that means 125 to start off with. So he already started with that amount of cans. He's just going to add to it. Okay, then we're going to graph the equation. So we need to graph a y-intercept of 125, and we need to go up by 25. So I'm going to be a lot more intentional about counting correctly on this one. If we start at 125, let's count by 25s on both. So let's do 25, then it would be 50, 75, 100, 125, 150, 175, 200, and then our top number would be 225. Okay, and again, this is going to be the aluminum, the pounds of, is it pounds? Yes, total pounds of aluminum. So pounds of aluminum. Hope I spelled that right. Okay, pounds of aluminum. Then across the bottom, that is how many weeks. Anytime you have time in math, time is on the x-axis. So this time happens to be in weeks. Okay, and so we're not going to count by 20. I think I said earlier we're going to count by 25. We're not going to count by 25 weeks. We're going to count by 1 week, 2 weeks, 3, 4 weeks, and so on. Okay, so our y-intercept is 125. So our first dot is here at the 125. So at 0 weeks, Riley already has 125 pounds. Each week is an additional 25. So now we're up to 150. 175, 200, 225, and so on. So that's your graph. And it wants to know how long will it take Riley to collect 400 pounds. So we didn't go all the way up to 400, so we don't know where our line is going to be as far as number of weeks, but we can easily calculate it if we know 400 pounds is the total P that we have here. So we're going to put 400 in our equation. And we're going to make it a video. So you'll have to go back. So we'll have 400 here, and then that equals 25W plus 125. Okay, so then you're going to subtract 125, sorry about that, from each side. 400 minus 125 is 275. You might double check that in your calculator. 275, yep, equals 25 weeks. And your last step is you'll divide by 25 on both sides. This is just solving equations. I know we've done this before. It's been a long time ago though, is 11. So 11 weeks is how long it would take to save that much. All right, number 5 is a boat rental service situation where you are charged just $20 to transport, I guess, the boat to where you are, and then you're charged $15 an hour to rent it. That's actually really cheap. It must be a little tiny boat. Okay, so write an equation. All right, so we are going to write an equation. I don't know why they didn't give us a lot of room, but we'll say, oh, it's y and x now. I like that. The total cost is y. And it is $15 per hour. So since it's per hour, that's where our x is going to go for each hour. So 15x plus the $20 upfront fee, transportation fee. So plus the 20. And now we're going to come over here and graph it. So we are going to start with 20, and then we're going to go up by 15s. So I think we should probably just count by, let's just do 10s again. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, and then that, remember, is how much money. Money, if you ever have money, it's always on the y-axis. And if you have time, which is hours, it's going to go across the x-axis. So this is going to be time in hours. 1 hour, 2 hours, 3 hours, 4, 5, 6, 7, 8, 9. If I'm going too fast, by the way, you guys can absolutely push pause and catch up. I know I numbered those really quickly. Okay, starts off at $20 just for a transportation fee. So put your first dot at 20. And for each additional hour renting this boat, you're charged $15 more. So we're going to go up to 15, which would be 35 for the next 1 hour. So we're going to kind of have to do in between dots, but that's okay. Another 15 per next one, another 15 per the next one, another 15, and so on. So here's your line. These should all be straight lines. You don't need to go get a ruler and make it perfect, but you should be counting up by 15 per 1 hour, 15 per each 1 hour. Okay, suppose you and your best friend plan to rent a boat for 6 hours. Well, I'm sorry to tell you that 6 didn't quite get on our graph. So 6 hours, we were close to getting it on there. It'd be somewhere above 90. But let's be specific. Let's not just guess. Let's actually use our equation and plug it in. If we know that X is the hours, then we're just going to plug in 6 for X because that's our hours. So Y equals 15 times 6, because we're wondering specifically about 6 hours, plus the 20 it takes up front to rent it. So in your calculator, 15 times 6 hours plus the $20 up front, 110. So that would be a $110 fee. All right, very last one. Let's take a look at this last one, and then you guys can turn this in. An attorney charges a fixed fee, that means upfront, of $250. And then that's just for the initial meeting. And then they charge $150 more per every hour. An attorney is a lawyer, so I'm sure if you guys didn't know that, lawyers make a lot of money. So $250 just for them to meet with you, and then $150 per hour in addition to that. So here's your equation. Y equals the $150 per hour that you're charged. So that's why I'm going to put an X there, because that depends on how many hours. $150 per hour, we don't know how many hours, plus the $250 up front, the fee that you're going to have to pay. So let's go see what in the world we should count by over here. Let's count by, like, I don't know, should we count by maybe hundreds? Let's try that. Let's count by 100, 200, 300, $400, 500, 600, 700, 800, 900. And remember, money is always your y-axis, and time, which this is per hour, is always your x-axis. I think, did I say x over here? Anyway, money is y, time is x. Okay, so 1 hour, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so up front, $250 just to show up. So your first dot goes right here between 200 and 300 is $250. $150 per hour. So we're going to go up 50 and another 100 per 1 hour. 150 per another hour. 50 and 100 per the next hour. 150 per the next hour. So it's going to go up basically 1.5 every hour, because it's 150. Okay, that is a very expensive cost. Find the total cost for meeting for 6 hours. So again, 6 hours is barely off our graph. We can't really determine it based on our numbers, based on our line here, but we know that hours is our X. So all we need to do is plug in 6. We need 6 hours worth of work from this attorney. So we're going to take 150 times 6 plus the $250 upfront fee. All right, so 150 times 6 is 900, plus you've got the $250 upfront, which is $1,150. $150 for just 6 hours worth of work. Okay, you may officially turn in both sides of this for your work for today. Be sure all of your work is shown, please.